Hello to all my students out there. This is your second in a line of OAA review videos. Guys, I'm really impressed at some of you, how you're working. Keep up the good work. I think you're going to do very well. Just do your best. There's no reason any of you should do poorly on this test. You're all very intelligent people. You just have to decide to do your best. All right, good deal. So first we're going to talk about trying to find the measure of those angles inside this regular pentagon. Regular means all the angles are congruent and all the sides are congruent. All right. Now, some of you are going to go, I don't know how to do this. Well, the first thing you're going to do is you're going to pick one of these angles. I would not pick the angle marked with X. I wouldn't do that one. That'll get confusing. But pick any other one. And I'm going to draw a line segment from that angle to all the other angles that don't already have line segments. And you see I've already divided that up into triangles. That's what I do. I never make my diagonals cross, okay, because I create angles that are not a part of the shape. Now this is 180 degrees, this is 180 degrees, and so is this. All triangles have 180 degrees. So all together there must be 180 degrees times 3, which I believe will be 540 total degrees. That's how many degrees are in the pentagon. If I add up, I'm going to call them, let's change the color here so they stand out a little bit. Let's call this angle A, B, C, D, and E. Okay? All pentagons have 540 degrees. Okay, now I don't need to know all their angles, but they're regular, so I do know that they're all the same. A is congruent to B, B is congruent to C. Congruent symbol looks like this. By the way, I had somebody today in study hall say they didn't know what the symbol is. This symbol here means congruent. It means equal measure. Congruent means equal measure. All right. If the total number of degrees is 540 and there's 5 angles and all the angles are congruent to each other, I can just take the 540 and divide it by 5. Well, that'll come out to be 108 degrees. That means that X must equal 108 degrees total. All right, now Y is cake because I know that X and Y together make a straight line. The straight lines have 180 degrees. How do I know that? Because they're half a circle. Look, the circle has 360. If I cut that circle in half, how many degrees are there from here to here? There's 180, half of the degrees of the circle. Right? So if I do 180 minus 108, I get 72 degrees. So angle Y is 72 degrees. All right. Go ahead, you try this one. See if you can find both X and Y. If you're having a hard time counting, it is called a nonagon. It has 9 sides. Go ahead and pause the video. When you're ready to see my answer and solution, you can unpause. All right, if you're unpaused, here comes my solution. The first thing I'm going to do is break this up into triangles. And let me see, I'm going to go 1, 2, 3, 4, 5, 6, 7. It looks like there's 7 triangles. In fact, I don't know if you know this, there will always be 2 less triangles than the number of sides. There will always be 2 less triangles than the number of sides. So if it's a 30gon, a polygon with 30 sides, there will be 28 triangles. All right, so I'm going to take 180. I'm going to multiply it by 7. It's going to be 0. That's going to be 6. Carry the 5. Should be 1,260 total degrees in a nonagon. There's 9 angles. We're assuming they're all congruent. I'm going to divide that by 9. And I will get 140 degrees. So X is 140 degrees. So I'll sneak that in there. Now, X and Y together make a straight line, 180 degrees. Therefore, Y must be 180 minus 140, which is 40 degrees. Okay, now, the next question I have for you is what happens if I add up all of the exterior angles? Well, let's see here. Let me get this picture clear. Hold on one second. Okay, now this 40 degrees is an exterior angle. To get the exterior angles, like all of them, I need to be consistent here. Hold on one second. Maybe I should do this with my fingers, see if it'll turn out better. All Now, we're assuming this nonagon is regular. Okay. So how many exterior angles are there? Angles on the outside of the nonagon. Well, if there's 9 angles inside, there must be 9 angles outside, right? And if you look, they're all 40 degrees, right? Because the shape is regular. All right, so I'm going to do 40 times 9, and I'm going to get 360 degrees. Oops, degrees. In other words, I get a circle if I go all the way around the nonagon. That should not be a coincidence. Up here, I know that this is going to be 72. If I continue and say that's 72, and then that's 72, and that's 72, and so is that one. All right, 72 times 5, hocus pocus, abracadabra, 360 degrees, because I walk in a circle around the pentagon. The sum of the exterior angles of any polygon is always a circle, 360 degrees. All right, let's review parallel lines here really quick. And I'm going to tell you that lines L, M, and N are parallel. Line P is perpendicular to line M. What does perpendicular mean? Perpendicular means they come together to make 90-degree angles. So those are 90 degrees. Well, if M and L are parallel, and sorry, P I didn't put in there, and P is perpendicular to M, it's also perpendicular to L, and consequently it's perpendicular to N. All right, now coming over here, I know that that angle there is 40 degrees, and this angle down here is 70 degrees. I should be able to figure out every single angle in this shape, in this picture. Okay. That makes a straight line, so therefore that's 140 degrees. Okay. There's something called vertical angles. Vertical angles make an X. And when you have an X, you know that this angle and this angle are congruent. So therefore that's 40 degrees. These two are also congruent. That's 140 degrees. Those are using vertical angles. Okay. Now there's other letters I can use. Let me move my X out of here. I know something called corresponding angles. And I can make an F with corresponding angles. Now I'll tell you the F can be backwards, forwards, upside down. It doesn't matter. So you see this F here? That looks like an F, right? And this angle here is 40 degrees, right? The other angle of the F down there is also 40 degrees because it's corresponding. I can make my F go backwards like that, and this angle here is 140 degrees, and the one down here is also 140 degrees. And notice that's consistent because those two make a straight angle. You see how simple that is? It really is. Those are corresponding angles. Now there's lots of correspondings around, but there's other types of angles I want to show you. I can find Z's. See the Z? And again, the Z can be backwards, turned on its side, look like an N. Z angles are called alternate interior angles. And so when you have a Z, this one here is 40, right? This one down here is congruent to it. It is also 40 degrees. Those are alternate interior angles. Okay, so we know vertical angles, they make an X. Let me see here. Vertical angles, that's like this one and this one, or those two. Those are vertical angles. And again, that X, that X could be turned on its side. Okay? Anything like that. And I think this one will be free. It can be at an angle, can be spun. Okay? Anyway, so those are vertical angles. Okay, I mentioned corresponding angles. Corresponding angles. Oops. Those are the ones that make an F. these two angles are the same if they're corresponding. The F could be upside down. It could be backwards. It could be upside down and backwards. It could be lying on its back looking at the stars. Those are the same. It doesn't matter. Let's see if this is free. No, it's not free. Let me draw one that's free so I can spin it. Okay. See, those are the same. Okay. The F could be like that. It could be like this, laying on its front. It could be like that. It could be facing the other way. Boom. Like that. Okay. So those are corresponding angles. All right, and then we talked about the ones that make the Z, alternate interior. Okay, alternate interior angles, and they make a Z. Okay, they could even make an N because an N is just a Z kind of rotated, right? They could make a backward Z. Okay, alternate interior angles. All right, so let's go back to my picture here. Let's see if I can find it. All right. Now, let's see here. I'll fill the rest of these out in black so they stand out. I've got an X here. That's 140 degrees, right? Okay, you see this X down here by the 70? That means this little guy is 70. So that one's 40, that one's 70. Hey, look at this. I've got a triangle. How many degrees in a triangle? 180 degrees, right? Well, if I add 70 and 40, I get 110. 180 minus 110 is also 70. So that's 70 degrees. If that's 70, this guy has to be 70. Look at this. See this big triangle right here? Where's that big triangle go? See that? Right? This is 70. This is 90. That one there must be 20 because I have to add them up to get 180 degrees. This one here must be 70, and I can use a lot of different arguments to prove it. This one here must be 110 because I've got this straight angle going on 180 degrees. 110 here, 70 here. All right, let's see here. Those are all 90. Let me come down here. If this is 70, this is 110. This is 110 because of vertical. All right. Let's see, this is 40 here. That means this guy is 40. This guy must be 70. This guy must be 70. This guy must be 110. 110. 140 right here. 140 right there. Okay. 40 degrees right there. I think the only one I don't have is this one. Oh, those two right there. Well, this better be 110 because 70 and 110 is 180. Therefore, that's 110. And there you go. I filled them all out. Piece of cake. All right. Let me see how am I doing here. No. Okay. I think I got through everything I wanted to get through for the review. So I will sign off, Mr. Lawrence, saying see you tomorrow. We'll get some more practice. Have a good night, everybody.